Okay, let's do some problems on 6-3 together. And let's start with this first page here. So notice I have this table pasted in, and obviously the decimal places have been cut off here in terms of what the sine, cosine, and tangent are of these various angles. And I give angle measures in degrees. And you only have degrees 1 through 44. And you only have sine, cosine, and tangent. So the question is, how can you find what I'm asking by just using this table? So I'm going to try to do like one of each type, kind of help you out here. And if you want to try on your own first without me walking you through, by all means try it. And then you can, of course, always check your solutions against mine, or you can come to this video. Okay, so looking at, let's just look at 1A, secant of 20 degrees. Well, I do have 20 degrees here, which is good, but I don't have secant. However, remember, secant and cosine have a nice relationship. It's a reciprocal relationship. So secant of 20 is the same as 1 over cosine of 20. So now I can use my table to look at what cosine of 20 is, and it's 0.9397. So that would be 1 divided by 0.9397. Okay, so that one wasn't so bad. How about B? B was cosine of 65 degrees. I've got cosine, don't have 65. Well, and it's not going to help me because I don't have 65. Doing secant obviously isn't helpful because I don't even have secant here. Again, I have cosine, but don't have 65. Well, something cosine has a relationship with, going back to the identities I just talked about in the identity videos, well, cosine and sine have a cofunction relationship. So cosine of 65 is the same as sine of 90 minus 65. Remember, cosine of theta equals sine 90 minus theta. In this case, theta would be 65. So cosine of 65 is the same as sine of 25. And now I can do that because the table, I go to my sine function and it goes to 25 and it's 0.4226. Okay, let us do another type. I think now you would be able to do C. I also, actually let's do D together. D is tangent of 80 degrees. Got tangent, but I definitely don't have 80 degrees. And, well, I could say tangent of 80 is the same as cotangent of 90 minus 80, or it's the same as cotangent of 10 degrees. Well, problem there is I have 10 degrees, but I don't have cotangent. But now we can use a different identity, which is the reciprocal identity, which is cotangent of 10 degrees is the same as 1 over tangent of 10 degrees. So again, first I use the cofunction identity just to get it to an angle that I could find here, which is 10. And then I use the fact that cotangent is the reciprocal of tangent. So it'd be 1 over 0.1763. Okay, and let's do one more type. Let me see what I want to do. Ooh, actually, maybe do a couple more because some of these get a little tricky. But it may be fun to try them on your own first and then come back and see if what you did was similar to what I did. All right, let's, which one do I want to do? Let's look at F, which is sine of 195. Now, clearly 195 is bigger than we have. Okay, let's do sine of 195. Let's see where that is. Sine of 195 is going to be in quadrant 3. And remember how if this were a special angle, a special triangle of a meaning 30, 60, 90 or 45, 45, 90, to evaluate it, I would create this altitude to the closest x-axis, and I'd be looking at what this angle here is. Well, this angle here is 15 degrees, because the difference between 180 and 195 is 15. So finding the sine of 195 is really the same as finding the sine of 15 with one difference. Because I'm in quadrant 3, the y-coordinate would be negative, so it's going to be whatever the sine of 15 degrees is, but I've got to put a negative sign in front of it. Well, now I can go to my table and do this. So it's negative. Let's go to 15 degrees, and the sine function is going to be negative, so 0.2588. It's going to be a similar situation when you, actually, let's do this next one. Let's do G. I keep on saying similar situation, but all these are slightly different. All right, let me move up a little bit. Let's do the next one, which is G. So G is sine of 115. I kind of find it helpful to draw where this is. It's going to be in the second quadrant. And if I think about drawing my triangle here, the difference between that terminal side and the closest x-axis, which is 180 degrees, is 65. Okay, so doing sine of 115 is the same as doing sine of 65. And just think about, is it going to be the exact same, meaning positive, or do I have to add a negative sign? And because the y-coordinate is positive here, I don't have to add a negative sign in front. So sine 115 will be the same as sine 65. Only one problem here. There is no 65 here. So in order to do that, I'm going to have to use something else. So remember, there's a relationship between sine and its cofunction, cosine. So I can use, this is the same as cosine of 90 minus 65. Or in other words, it's the same as cosine of 25 degrees. And now I can go to my table and see that that's 0.9063. Okay, so that was the first page. And again, try the ones I didn't do as well. Hopefully I've given you enough so that you can get a feel for how to do all of them. And then I'm going to do a second video for number 2.